Hey folks, I'm going to explain how to analyze the top half of a STATA regression output. Bottom half gets covered quite a lot, so that's your salary, row, cons, coefficient, standard error, all that stuff. That gets covered quite a bit, especially towards the start of a course. Top half kind of gets neglected somewhat in a lot of courses. There's a lot of understanding to be had up there, and importantly, it almost always comes up in exams. It's a key part of understanding what your regression is actually doing and how powerful the regression is in a sense. Okay, so I'm going to explain abbreviations quickly. SS, as we see up here, is sum of squares. Okay, df, degrees of freedom, ms, mean of squares. Hopefully we've seen this all before. I'm going to run through how it all works, and those abbreviations will hopefully become more clear as I go through. Okay, so we're going to start at this first row here, the one with SSE, model, all that sort of stuff, okay? So what is SSE to start with? Now, tricky thing is, you might have seen it as ESS, and this is how I like to think about it. They are the same thing, it's just flipped. They move the E across. So ESS is explained sum of squares. Explained sum of squares. We're just going to use abbreviation as up top. Okay, so what is it actually trying to get at here? It's somewhat trying to explain the predictive power of our model. Okay, so what I'm going to do, I'm going to draw the average of salary. So we're just going to denote that sal bar. Okay, so that's average of salary. That's where salary tends to just on average, right? Okay, so let's say I have some value over here. I have some, we're going to label this for convenience yi. Okay, so I can talk about it in more general terms rather than labeling it as salary. So I have yi. Now I have my regression here, this line here coming up. How much of this variation in salary / y is explained by my regression in this case? Well, it's actually this. Try my best. It's this amount here. Okay? So it's the difference between our regression here. I'm going to label the regression reg. Yeah. That's our regression and the mean of salary. Okay? That's kind of how much the model is explaining. So now, in slightly more mathematical terms, I will label this. So y hat is this point. Y hat is what our model is predicting. Okay, so our regression with whatever this amount of education is predicting this level of salary. Okay, but in actual fact, it's greater. Okay, so we have yi, which is actual, y hat, which is predicted, and y bar, which we're going to just kind of loosely change from salary. Okay, so that's ESS kind of explained in a graphical sense. It's the difference between the regression line and the mean. Okay, now talking about this more mathematically, we can note it as, so it's the sum of squares explained, right? Or explained sum of squares. So it's the sum of squares. So that's kind of the trick for this next bit. So we're going to use sigma. So we're going to say ESS is the sum of, and we know it's y bar, our prediction from our regression, minus by the mean of y. Okay. Now, importantly, you need to make sure that this is squared. Okay. Now, why do we want this to be squared? If you are quite astute, you may have noticed that if we don't, we can have negative values for this. Okay, so let's say we have a point here. Okay, the average is actually greater than the predicted value of y here. Okay, so this would lead to negative values, and as an intrinsic property of the square, obviously we can never have negative values. It will sum to give us something meaningful. Okay, so we just don't want, we want to know the total predictive power. And if we have cancelling out with negatives and positives, Obviously, we're not going to get an accurate number. It could just trend towards 0, and that's not super useful. So consider it as a usefulness measure. Okay, so that's ESS super quickly. Let's move on. So ESS, sum of squares is this. Okay, degrees of freedom is just 1. It's always going to be 1 for these simple regressions. Mean of squares, we can sort of just observe that. We can do that division there, and then that's quite obvious. Now we'll move on to residual sum of squared. So SSR, again, equivalently RSS. So residual SS. So this is how much our model messes up in a sense. This is the sum of the residuals. And just recall that the residual is the difference between the actual value we get and what our model predicts. Okay? So up here, so using this previous example, what I might do, actually I'll leave it in there. So we have yi and we have y hat. Okay? Now, we can see the residual quite clearly in this one. The residual here is just this line, is this amount. So that's our residual. That's the difference between yi, the actual value, and our predicted value given to us by the regression. Okay. So that is, again, quite straightforward. More mathematically, it's the sum of... Now, hopefully you can sort of see where I'm going with this now. So just graphically, it's yi minus y hat. Okay? So I'm hoping this makes sense, kind of combining graphically and mathematically. That's kind of the approach I like to take generally. Okay, cool. So now, what is total sum of squares? That's kind of quite nice and straightforward now that we have the rest of this. So this is total SS now. Now, quite cool. It is actually just both of these combined. Okay, so it's the natural variation in yi from the mean. So it's going from yi up the top here, so y up the top, all the way down to y bar there. So it's this whole amount. Whole amount is total. So hopefully mathematically you can see this too. It is yi actual, whoops, that's a big one. Yi minus y bar, which is our average. Okay, so it's that total amount there. Wait. Okay, so hopefully that makes a bit more sense now. So sum of squares isn't that bad. It's just saying literally sum where explained is just how much our model can do, how much our model explains. Well, it's what our model explains, like minus the average of that dependent variable. And yeah, so now the trick with this thing over here, the mean squares on the right side, it is a simple division by the degrees of freedom. Okay, so it's all pretty straightforward with that in mind. So this side, mean of squares, is pretty nice and convenient, understandable. Hopefully model, residual, total all make sense now. Just to be clear, explained sum of squares comes up as model. It's what's explained by our model. Okay, residual is just residual. That's nice and easy, and that's where our model fails, and the difference between predicted and actual. Total is just kind of the sum of the two squared. Okay, so hopefully that all makes sense. I'm going to leave it there, I think. Let me know if there's any confusion anywhere. But yeah, I think that's pretty much it. Okay, cool. All right, guys, thank you very much. And I will see you next time.